The overall goal of this procedure is to synthesize non-uniformly praseodymium-doped strontium titanate ceramics with improved thermoelectric properties. This is accomplished by first preparing the praseodymium-doped strontium titanate powder by a high-temperature solid-state reaction with a series of intermediate grinding and mixing. The second step is to densify the prepared powder into bulk ceramic discs using a fast-heating spark plasma sintering technique. The final step is to perform the measurements of thermal and electronic transport properties as a function of temperature on the sintered ceramics. Ultimately, these electronic and thermal transport measurements are used to show the improvements in the thermoelectric power factor and figure of merit.
The main advantage of this technique over existing methods, such as solid-state reaction with conventional sintering or hot pressing, is that significant improvement in carrier mobility and thermoelectric power factor can be achieved using grain boundary engineering by taking advantage of high heating rate capability of spark plasma sintering technique.
This method can help answer questions in the field of thermoelectric oxides and the field of electroceramics, such as the potential of strontium titanate for high-temperature thermoelectric power generation applications, as well as the modification of electronic properties of this oxide.
Though this method can provide insight into the thermoelectric properties of strontium titanate, it can also be applied for other systems such as electroceramics for applications from solid oxide fuel cells to ferroelectricity.